Alright, so here we are with the slope formula. Much of what's happened in here has kind of been introduced in the previous, or at least hinted to in the previous lessons. So, we're going to find slope this time by using a slope formula. So instead of just using rise over run, or change in y over change in x, we're going to actually have a formula. So here's our slope formula. The problem with the slope formula is that there's a lot of little sub numbers. So we do say these as x sub 1, for instance, and y sub 1, and x sub 2, and y sub 2. I like to think of the little 1 and the 2 as kind of the labels of the first point and then the second point. Because what's going to happen is we're going to have 2 points, we're going to be given coordinates of those points, and we want to find the slope of the line between them. So slope is represented by the letter M. It's because its Latin is modus, and so anyway, so either way, M is slope. And so what you need to do is, as we talked about, your rise, or your up and down axis, right, is the y-axis. And so we're going to do the change in, meaning subtraction, of the y's over the subtraction of the x's, which is again what we actually already did in the previous lesson. We just didn't know that we were doing it necessarily that way. So here we are with our complete formula now, subtracting your y's on top, subtracting your x's on bottom. We do want to make sure that as you're doing this, you are doing this second point minus this first point. You want to make sure that those two are happening first versus second. Alright. So here we are. They want you to find the slope by using the slope formula. So our slope formula again says that we have y2, take away y1, and all of that is in a fraction with x2 and x1. Now to help myself out, I always go ahead and label. So this first point, right, is x and a y. Second point is an x and a y. And then I'm going to put little 1's here and little 2's here. Now, it doesn't actually matter which one you label as the first and the second, as long as you continue that way as you're going through the problem. So again, I could change each of these little 1's to a 2, and each of these 2's to a 1, and I would get the same slope. So, we're going to go ahead and fill these in. So the formula has your division and subtraction going on, but y2 is what I'm going to look for first, so y2 is 1. Then I'm going to subtract y1, and y1 is 5. And then from there I'm going to take x2, whoops, alright, and x2 is going to be 8. And from that we're going to subtract x1, which is 2. So as we simplify, 1 minus 5 is going to make negative 4. And 8 minus 2 is going to make 6. And of course, because we can, we need to reduce as much as we can. So I divide 2 to the top and the bottom to get negative 2/3 as our slope. Remember, we are not doing decimals. So make sure that we don't do that. Alright, this next one here, we've already done rise over run, so if you feel better doing rise over run or you like it more, you can actually use it. It does say use find the slope, so it doesn't necessarily mean that you have to use the formula, but I guess we'll do it in both ways just so you can see. So if we do the rise over the run idea, we're going to end up rising 1, 2, 3, 4 squares, and running 1, 2 squares. And so via rise over run, our slope is considered to be 2. For the formula, we have our y2 minus y1 over x2 minus x1. And so that means that if we go through and label each of these, if this is our x and this is our y, it's the first point. So that's your x1 and y1, and then over here is an x and a y, and we'll call that the 2, the second point. So if we fill in our formula, instead of a y2, we're going to want a 2. Instead of a y1, we're going to want negative 2. So of course that means that minus and negative would become plus. Then we're going to have x2, which is 0, minus x1, which is negative 2 again. I still take the time to label all of my points because what happens is most people will end up actually subtracting the x and the y of one point on top and another point on bottom. Or you might flip the fact that this one becomes x1 minus x2 or something like that. So pretty much every time, especially with our subtraction, you do want to be careful. So this second one here becomes 2 plus 2, and then we get 0 plus 2, because again, minus and negative is plus. So that means we have 4 over 2, or 2. Now, of course, which one was faster? This one. So the problem, of course, is that not all the time do we have a graph, and so you do want to know it that second way as well. All right. So what we're going to do here is notice that this entire table, unlike the last lesson, this table shows a linear relationship. That means that we have a constant slope every time. So it doesn't matter if I pick these 2 points, or these 2 points, or these 2 points. If it is a linear relationship, every single change between one and the next is going to result in the same slope. So we can go ahead and pick whichever of those sets of points we want. I could even pick this first one and this last one, so it doesn't really matter as long as you remember which ones are your x's and y's. So I'm going to go ahead and label them. Of course, this is my x row, and this is the first one that I'm given, so we'll go ahead and put it as x1, and this is y1. And then for fun, we'll just do this last one, so x1, 2, and y2. Alright, so we're going to do our slope, which is again y2 minus y1 over x2 minus x1. And so filling it in, of course the subtraction and the fraction stay. My y2 is going to be negative 1. My y1 is going to be 5. Then on the bottom we have our x2, which is going to be 1. And our x1, which is going to be negative 2. So if we put all those together, the top becomes negative 1 minus 5, so negative 6, and the bottom becomes 1 plus 2, because minus and negative is plus, so we get 3. And of course that can simplify to be negative 2. Now let's say you chose some other points, you would still get negative 2, because this entire set is a linear relationship. If it just said what's the greatest slope, like we did in our last lesson, or the least slope, or the rate of change, that is going to be different than the fact that the entire table is that one slope. Alright, so here we are with an application. The graph shows the average electricity costs in dollars for operating a refrigerator for several months. And we want to find the slope of the line and then tell what the slope represents. And this rate of change is a very applicable idea, so just so that we can kind of see what it does in fact mean. So they do give us 2 points here, so we may as well use those as what we're going to do for our slope. So the first thing is to actually get the slope, and then the next one is what does it represent. So, that's a bad M. Okay, so our slope again is y2 minus y1 and x2 minus x1. And so we go through and label. So let's see. This could be my x1 and my y1, that's fine. This can be my x2 and my y2. And so if I fill them in, I'm going to want a y2 first. So y2 is 24. From that I'm going to subtract my y1, which is 12. Then we've got our x2, which is 4. And our x1, which is 2. So if we simplify, 24 minus 12 is 12. 4 minus 2 is 2, but of course 12 divided by 2 is 6. So we do know that our slope is 6, but that doesn't necessarily give us what it represents. So we have to remember what does our y represent and what does our x represent. So our y value here is going to be the cost. And then our x is the number of months. So if we actually look at this value, 6 is not actually just 6, but it is in fact 6 over 1, right? Any whole number can be divided by 1. So what does that mean? That means 6 is our cost, and 1 is how much time we have, so per month. So what does this mean in regular people words? It means that it's going to cost $6 per month to operate the refrigerator. All right. So again, $6 per month to operate the refrigerator. And of course, you can't just say slope is 6, right? Because you do need that interpretation of what does it mean. And since 6 is on top, it has to do with the y value. And since 1 is on bottom, it has to do with the x value because of how we set up the formula, where y's are on top and x is on bottom. All right, then the next one here, we're going to find the slope from an equation. All right, and the interesting part about a slope in an equation is that the slope is the thing next to the x. Well, of course, that means that as you're looking at this, you're saying, oh, well, then 4 is the slope. Well, our standard equation is going to be y equals mx plus b. All right, m, of course, is our slope, as we've been doing, and b is our y-intercept. So what we're going to do is change this formula that they give you into what we're calling slope-intercept form. Exact name for the fact that there's a slope listed and an intercept listed right away, right? So what we're going to do is take the time to rewrite 4x minus 2y equals 16 so that y is by itself. So how do we do that? Well, it's a positive 4x, so let's go ahead and subtract 4x over to the other side. Then after we take our 4x away, we're left with negative 2y equals negative 4x and 16. All right. You'll notice that I wrote this so that the negative 4 was first, because most of the time our x is shown as first, and then our value is shown second, or our constant. And you'll notice also that I did plus 16, because this is technically a positive 16, right? We just don't write positives in front of all of our numbers. All right, then the next thing to do, because we're trying to get y alone, is to divide by that multiplier. Anytime that you divide by that multiplier, technically every piece over here is divided by it as well. Since both of them are even, I do want to split it up so that I can make it more simpler. So we've got y equals negative 4 over negative 2 becomes 2 with an x next to it. And 16 over negative 2 makes negative 8. So as you can see here, if this is the same as y equals mx plus b, my intercept is negative 8, but of course that's not what I'm looking for. I'm looking for my slope, and my slope is 2. Alright, so as long as you can take the time to rewrite something in y equals or slope-intercept form, you can then see that whatever is next to the x is your slope. Don't include the x, okay? It is not 2x, it is just 2. We're looking for the value, not the number. You'll notice that in all of these over here, I've never had an x next to them, so it doesn't change when you just happen to have a formula. Alright, then we've got a little quiz here, which is kind of the same as what we've been doing in the previous ones. So if you want to take the time to do that, you can go ahead and do that. I'll give you the answers here in a minute, but I would like you to try them by yourself. And so here we are with our answers. The first one here, you should have had a slope of negative 1/6. After that, if you find the slope for this tour bus, you're actually getting 50, which means 50 over 1, or 50 miles in 1 hour. And then this last one here, if you rewrite it as y equals, so that you can see the slope sitting there, you have a negative 1/2 next to the x. That means the slope is negative 1/2. Alright, so that is our Chapter 4, Section 4 notes on finding slope using that formula, using an equation, and then also potentially from a table, which is a bunch of points as well.